This is recitation 2 and problem 5. For problem 5, we will have charge minus 2q at the origin, x0. We will have charge q located at xd, and we want to find a point on this axis x where electric field is 0. So we want to find a point where electric field at this particular point, let's call it x star, electric field is 0, and electric field is a vector. Find the point where electric field is 0 if you have these two charges. How to approach this problem? So let's try to place a test charge somewhere, because you remember that electric field is Coulomb's force divided by positive test charge. I will use test charge Q0, trying to find out where should be this point. First, I will try to place this Q0 between these two charges. Let's say here, Q0. Okay, so then this Q0 will experience a repulsive force from Q and attractive force from minus Q2. So both forces will be in the same direction. There is no way that net force will be 0, which means that no hope that electric field will be 0. We need to find the point where net force is 0 to have electric field 0. Let me try again. This time I will place Q0 to the left from minus to Q, right here. This is my Q0. Okay, so minus 2q will create attractive force to the right. Q will create repulsive force to the left. Oh, we have hope. So this is not to the scale. I just draw the direction. So these two forces are in opposite direction. Is it a possibility that we can place Q0 here and have net force acting on Q0 0? Let's write the magnitude of Coulomb's force. We know that magnitude of force between two charged particles is k, then magnitude of one, magnitude of another one, divided by distance between them squared. So now let's look at this Q0. So the force that minus 2q exert on Q0 will be always greater than the force exerted by Q. So I need to draw this vector longer than this. This should be tiny. Why? Because I have product of charges in the numerator. So I have 2q versus q. In this case, I have 2q q0 versus just q q0 versus q q0. And in denominator, in this case, I have smaller distance, much smaller distance, x smaller than I have here. So here is distance, here is distance. I have larger numerator and smaller denominator, which makes force exerted by minus 2q always greater than force exerted by q. This doesn't work. So this location also doesn't work. Let's try the third one. And the third one will be to the right of q. So this is now my third attempt, and I put Q0 right here. Charge Q will create repulsive force. Charge minus 2Q will create attractive force. And there is a hope that these two will be equal each other, because charge Q is smaller than 2Q, but it is also at the smaller distance. So hopefully it will compensate for larger charge, but the distance is larger, and distance is in denominator. Let's try to write net force exerted on Q node at this point. How we will call it? Let's call it X star. Arbitrary, not arbitrary, but point X star, where net electric field or net force will be 0. We will write net force first. So what is net force exerted on Q node located at this point X star? Net force. Net force is vector sum of two forces. This force is along X, so I will put immediately X component of the force. First, I will write force exerted by Q on Q node. This force is to the right. Projection is positive. Magnitude is K. Q node divided by distance between Q and Q node squared. This is the distance. This distance is X star minus D. X star minus D squared. This is distance squared. And X component of force exerted by charge minus 2Q is negative. It is in negative X direction. So we put minus K. Now magnitude of this charge, magnitude is 2Q, Q node, divided by distance squared. Distance squared is distance between this minus 2Q and this Q node. It is this distance, since this charge is at the origin, so the whole distance is X star. And this net force, X component of net force, has to be equal to 0. So we have one equation and one unknown variable, X star. Let's solve for X star. Let's find X star. So I bring this expression to common denominator. I have here, let's divide by K, both sides of the equation. Let's divide by Q naught, both sides of the equation. And now we will have 1. First, I just divide. I have 1 over X star minus D squared minus 2 over X star. I forgot squared here. So it is X star. I made a mistake. Let's fix it. X star squared, distance squared. So it is X star squared. And this is equal to 0. I bring it to common denominator. It is X star squared minus 2 X star minus D squared. And this is equal to 0. Just multiply by denominator both sides of the equation. So this is my final equation to find X star. This brings me to X star squared minus 2 X star squared minus here twice product of X star and D, and this minus plus 4 X star D, and then plus D squared times minus 2, which brings me to minus 2D squared. This is equal to 0. Let's simplify it. I have X star squared minus 2X star squared. It is minus X star squared plus 4X star D minus 2D squared, and this is equal to 0. Let's multiply by 1. No reason, I just like it this way. X star squared minus 4D X star plus 2D squared. This is our quadratic equation. So X star is equal to half of this coefficient. We will have 2D plus minus square root of 4D squared minus product of this 2, which is 2D squared. And we have, let's simplify it, 2d plus minus 4d squared minus 2d squared is square root of 2. D squared square root is just d. We have two roots, 2d plus minus square root of 2d. Which one we will choose? We need this one to the right from this point d. So we choose plus. X star will be equal to 2d plus square root of 2d, because minus 2 and square root of 2 is 1.4, will bring us to the point which is not to the right from point D. So we know which point we need. This is our final answer. So electric field is 0 at this point X star, which is 2D plus square root of 2D.